Hello everyone and welcome to another live stream. My name is Luciano and today I'm here to play with Rust and trying to learn a little bit of Rust, hopefully. So this is something that I've been doing for the last couple of years. I've been doing some frequent live streams, probably once a week, doing mostly Advent of Code and other small projects, generally with Roberto, my friend, who is doing a lot of amazing animations on Advent of Code. And yeah, today I'm here because I've been playing lately with a little bit of a small side project, trying to call an API called Last.fm, which basically allows me to get data from effectively music that I listen to. And we have been using that side project as a way to play with what does it take to make an HTTP request, doing that in an async way, and also using serde to deserialize JSON, building custom structure, and use serde in a bunch of different ways to effectively try to deserialize some JSON data into custom structure. And all of that has been fun. And now the next step that I want to do is basically trying to effectively, because this API is a paginated API and you can go through all the different records, I would like to create some kind of a client that easily allows you to iterate through all the different pages. And of course, every time you want to go to the next page is a new async request. So I was thinking that it would be nice to try to use some kind of abstraction like streams or async iterators, which apparently is something that is not really fully formalized in Rust yet, but there are some interesting crates that we could look at and maybe they can help us to build something actually functional. So I have to actually introduce a new guest, which is here with me. You can probably see it in the background. We have a little Ferris there that I got from Rust Nation UK. I'm really glad for this nice present, and hopefully Ferris is going to be helpful. Okay, so let's actually start to share my screen, and I want to start by showing you some refactoring that I did while I was on my plane to get to Rust Nation UK. And I don't know if you remember for last time, actually, I did commit all of this, and actually let me share with you the repository again, if I can find it. But I did a little bit of refactoring because I wanted... Oh, Chris Biscardi. Hey Chris, how are you? Good to seeing you here. Thank you for joining. I really love your videos, so it's really a pleasure to have you here. Alright, so let me share again this repository in the chat. And basically what we want to do today is, first of all, let's have a quick look at the refactorings that I did. And I did learn a few interesting things about serde, so probably worth sharing some of those. And then we'll try to look at some of the crates that I was exploring when it comes to do async iterators or streams, whatever we want to call them in Rust. And hopefully we're gonna get some of them to work. I never tried them yet, so it's just looking at the readmes and see they actually make sense, but let's see what kind of surprises are we gonna find there. All right, so by looking at the code, the first thing that I want to show you is that we had everything in our main file and it was a little bit messy. So the first thing that I did, I created a LFM folder, and inside this LFM folder, I started to organize all sorts of different custom structs and then kept things a little bit more separated and testable. So let's actually have a quick look through all of them. So the first thing that is probably worth mentioning is that now we have this mod.rs, which is pretty much copy-paste from our previous version of the code, but then we separated some of the structs into their own files. For instance, we have artist, which is very simple, to be fair. This one didn't really require any custom deserialization, so it's just a bunch of derived traits. And then we have this image set. This is actually one of the ones we worked through in our latest stream, and where we learned about the possibility in serde to implement this custom deserialized trait. So rather than deriving it, we could implement it ourselves, and basically we can write some custom code to actually populate the values in this struct. Not gonna go through this code too much, but basically the idea is that you can use raw.json, for instance. Here we just deserialize to a vector of hash map of string, which maybe not the most optimized code because we are allocating all the stuff just to take the data and move it around into a custom struct. But for now, this is probably good enough for what we want to do. And here the issue was that we wanted to have a struct that is a little bit more predictable. We know we are going to find a small, a medium, a large, and an extra large picture, for instance, in this image set. But the way we were getting the data was kind of an array, and then different items would have, oh, this is the small one, this is the large one, not necessarily in the right order. So it did make sense to convert this in a more predictable struct where you know which kind of properties you can expect, and then the value might be there or not. Then let's have a quick look at last.fm date. This is actually a new one. So last.fm was giving us just a Unix timestamp, but we thought that it did make sense to have something like Chronos to actually have a proper object representation of a moment in time, and then we could use that programmatically, for instance, if we wanted to do any operation based on time. So what I did here is again use this manual implementation of the deserialize trait from Serde. And basically what we did here, again, I took the shortcut of deserializing to an hash map string. Then I was reading the UTS field. And if it's there, I'm going to try to create Chronos datetime with that. Now here there was some interesting and unexpected complexity, and this is probably just because of time zones and the fact that dates are always a little bit weird and unpredictable in different ways. So basically you are not always guaranteed to be able to take a Unix timestamp and actually get a valid date in a given time zone. So here there is a little bit of extra code that makes sure that you are actually able to build a datetime object in Chronos, otherwise it's just going to be an error. And the other interesting thing is that I was using a new type pattern, so I'm creating actually my wrapper struct to be able to do this deserialization, and then I'm also implementing the deref trait to actually make it look like if my custom struct is a pure Chronos struct. So I can immediately access all the properties and methods that are available in a Chronos type. So nothing fancy here. I also have a test, and this test seems to work as expected. Then the other thing we did, we have a track, and track is something else that I extrapolated and cleaned up a little bit, and actually ended up doing, in this case, this is probably the biggest refactoring from last time. So if you remember, we had two different kinds of results in our API. So every time we call the this API, which is basically giving us the historic set of music or songs that I've been listening to, we always get two possible types of records. One type of record is if I'm listening to a song right now, that will be a type of record, and it's giving me a bunch of metadata, but it doesn't have any timestamp because that song isn't completed yet. Or other types of data is when I've been fully listening to a particular song, that gets registered in my last.fm profile, and at that point that particular record has a specific timestamp. Now in our previous version we had like a boolean flag saying playing or now playing, something like that, true or false, and then we made the date time optional. I thought it was actually much better for making this code much more usable to create an enum and differentiate between now playing and recorded, and the now playing track doesn't have a date time, and while the recorded one does have a date time and it doesn't have to be an optional anymore. Because of these changes, I have some more helper function. For instance, you can get I totally rewritten the deserialization in a custom way. It is a little bit verbose, but it's basically doing all the same logic we were doing before, and eventually we are able to check if there is an attribute that says that this song is now playing. We parse that, we have all the data and we can construct a now playing. Otherwise, we should have a datetime. We parse the datetime and we build the final object. So at this point, and I also used this thing to write some tests. And actually another interesting thing, and this is actually a big thank you to Chris Biscardi, if he's still listening, because I recently watched one of his videos and I discovered this snapshot testing utility. So I actually used here a crate called Insta, which allows me to do snapshot testing. And basically what I'm doing is, if I take some JSON, I am able to deserialize it correctly, and the struct should look what I expect. So you can see here actually how easy it is to use Insta. I take some JSON from there, which probably I should move it to a fixture file, but for now it's fine. And deserialize it using serde from string. And then I just check with Insta, does it match the current snapshot? And that the first time I used that, it's actually gonna create a snapshot file that I will need to kind of approve or not. And once it is approved, it ends up here. And if I change anything, basically the snapshot is not gonna match, and then it's going to tell me this doesn't match the expectation. So this is basically a way to, when you have complex objects, and of course you don't want to write a lot of code yourself to make sure that every single property is matching your expectation, you could create a snapshot, record that, put it into your repository, and then the next time that you do a change, if you are breaking that snapshot, it kind of visually shows a diff, and then you can decide, yes, this is what I was expecting, so approve this new version of the snapshot, or maybe it doesn't match your expectation, and then you realize you have some kind of a bug and you can fix your code. Actually, let me see if it is easy somehow to show you a demo of that, because I think this is pretty cool. And let's see, how can we do that? We can go here to track. I can probably change one of these values. Actually, let's make now playing to false, because this is probably going to be interesting, because it's gonna actually, I'm thinking if I do that, this is probably a genuine bug. So let's revert this to true and let's change something else. Let's pretend that this URL, rather than being nothingness, is going to be, I don't know, nothingness2. So now if we run this test, it should fail and show us some kind of interesting difference. So you see that Insta is actually quite nice in the way it shows us the error, because it's basically giving us a very nice diff saying everything else was okay, but this one particular field is actually not matching our expectation. And in your snapshot, old snapshot, the red one, we had nothingness, while the new result has nothingness2. And if I wanted to approve that, I think that the command, you can install, let's switch to the CLI. I did install a cargo Insta, and let me make this a little bit bigger. And cargo Insta basically has a bunch of subcommands, and one of the subcommands is review. And at this point is actually showing us the latest issue with our snapshots, and we can say accept, reject, skip, or hide info. For instance, if I want to reject this change, I can press OR. And now if I run cargo test again, this is still gonna fail, but we can do review. And at this point I can accept it if maybe I fixed a bug and now I have the correct snapshot. Now at this point, if I do cargo test, the test is going to pass because we effectively submitted the new version of the snapshot and we say this is fine. And basically we can go back here and see that the snapshot was effectively changed. Somewhere here we should have nothingness2. There you go. So this was another nice change. Now, the next thing that I want to do is basically create this client, and I create a little bit of scaffolding for it. And the idea of the client is that you initialize it, and of course you need to provide an API key to this client and a username, and then there is a bunch of state that can happen there. And you can effectively do two things with this client. You can either say now playing, and it's going to give you a now playing track if there is any. Like if you're listening to some music right now, it's going to be a value, and that value is going to be the information about the track that I'm listening to right now. And otherwise, the other thing that you can do is start to go through the entire history of recent tracks from the most recent to the oldest in my archive, and that's basically giving us a stream. Now, I didn't implement any of this, so this is just scaffolding code. My intention is to create a generic function that can load the next page, and we should be able to do that because we have some of that code in the main, and then implement these recent tracks by basically creating this stream. And here we will need to learn a little bit more about this stream create. And here we can write some code where you can use this yield keyword, and that yield is going to yield every single page, or maybe every single track. We will see what's the most ergonomic way of doing this in a given page. And when we get to the end of the page, we'll fetch the new page, and we keep going until there is no more pages left in the history. Now, feel free to ask any question in the chat, any comment, if you think this is a stupid idea, or if you have any suggestion for, I don't know, other crates or other ways of doing this. I'd love to hear from you. Keep in mind that I am a little bit of a Rust noob still, so always open to suggestions. I think this is more an opportunity for me to learn than an opportunity for me to teach. So please, 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 please help wherever you feel you can help. Okay, so let me think what's the first thing that we could do. Probably the first thing that we could do is to start to implement this load next page, and then we can change our main, or maybe create a new test in this file to actually try to call the API and try to get some data out of it, and then we'll try to implement the next page. By the way, another thing that I didn't mention is that the way I want to fetch the next page, to keep it somewhat stable, because I might be listening to music as I go through this series of API calls, so the data is not going to be stable. There will be new records in, and I might have that problem of the sliding window where I might get either duplicated records, or maybe I might miss some records. So one way to make it stable is to keep the latest timestamp in a page, and the lastfm API as a way to say, give me the next page starting from this timestamp. And this is how we are going to be doing pagination, basically timestamp based pagination. So here I created a bunch of state where we have the data in the current page, we have the next timestamp, as more pages, total tracks, retrieved tracks, and so on. We might have to change this, it's a little bit of a premature guess, but the idea is that we initialize this client keeps some kind of internal state, and then as we do this asynchronous iteration, this client will maintain the state and yield all the items that we want to get. Okay, so let's go back to the main and let's see how we do a request. I was using here, I was using a request as a way to do asynchronous requests. So we can probably copy most of this code to effectively have a base on how to fetch a page of results. So let's actually do this. Yeah, this is probably good enough for now. And then we'll need to introduce the time-based pagination later, but let's see where this goes. So basically load the next page. What we want to do is this, and we can probably put this base URL in a constant somewhere at the top. Let's see if I remember how to do this. That should be it, right? Ooh, Copilot was actually very helpful there. Yeah, that sounds legit. And here we don't need this anymore. What we can do is basically this base URL. Now we need to import the URL crate. Was it request URL? Was not. We were using URL. I don't know if it's the same that requests uses internally, but let's skip this one for now. We know that works. Now last.fm API key is going to be self dot API key. I think I might need to do as str. Okay. And now at this point we have, okay, this one might fail. I'm kind of tempted to go with an unwrap for now. Or I suppose we will need to figure out a way to return a result from here. I'm just gonna go for an unwrap right now, and I will put a to-do, make this method valuable and propagate errors. Okay, then the next step is that we want to, of course, we need to make this method async, right? Because we want to use await. And yeah, we definitely have a lot of cases where things can fail there. So what's the easiest way that we can do an error? Probably let's do something like this. Where we can basically say, well, for now, let's just say to do, so we don't get annoying errors. But basically here we can also say question mark. Now this is not the nicest way of doing errors. Ideally we should have a proper error type for this library. So probably a good idea to remember about that. Create proper error types for this client. Okay, now we are saying recent tracks. We probably need to import that. And at this stage, we are going to have a set of recent tracks. And if we look at recent tracks, what do we have? We have this dot recent tracks. And then what we can do, this code from Copilot is actually close enough, I suppose, to what I wanted to do. So again, we will get a page at this stage, and this page is going to tell us if I'm listening to a song right now, that's going to be one of the records in the result, and then we will have a bunch of historic records. So what we can do is basically iterate over all the single tracks, and then we can see, okay, is this a now playing song? If it is, we are going to store it as now playing. Otherwise, it's just going to go in the array of items in this current page. So I think this one will probably do. Actually, we need to do this a little bit different. We can do a match statement where we match basically T, and T can be of two different types, pretty much. So it could be of type recorded. Why doesn't it like that? Oh, I think Copilot is giving us bogus suggestions. So here we have a enum type track, and track can be now playing or recorded. So we have to say track, and then we have recorded or track now playing. and track needs to be imported. Okay, at this point we can have a recorded track or a now playing track. If it is a now playing, what we can do is basically say this. Let's leave alone the retrieved tracks for now. And now, yeah, we are not even processing the number of total tracks. We might need to do a little bit more work to do that. Actually, let me show what I mean by that. So if we do restore our main and we deserialize this to a JSON value and just print the result, it should be more obvious what I'm talking about. Now here I'm not gonna have this, and we're just gonna print the response. Okay, let me show you what it looks like. So this is the API response. Actually, there is a lot of data, so I'll need to run this from here. Cargo run. Let's do it this way. So we have here recent tracks and attributes, which we are not even deserializing. So we could improve our recent tracks structure to capture all this data. For instance, this is saying that this is the first page, there are 50 items per page, this is the total number of songs that I have in my database, and this is the total number of pages, and this is the user that we are using. And then at that point we have an array of tracks, and every track has all the data related to it. So how do we do that? I would say the easiest thing we could probably do is to do a custom deserializer in here, but I will leave that for later. So let's add a to-do here as well. To do capture metadata as follows, and we can probably copy from here. If we rerun this code, this. It's also interesting that Last.fm, because it's kind of a very old API, which is originally built as an XML or PC style API, they don't really use JSON data types very well. Everything is pretty much a string. So here, even if you have numbers, they are encoded as JSON strings. So we will need to do a little bit of extra work there to deserialize these values. So that's why it probably makes sense to deserialize them with a custom deserializer. Okay, so let's leave that for later. So for now, what we just want to do is to store the now playing song, and then for every recorded song, what we want to do is basically say self dot retrieved tracks. What did we call it? Actually, we have a current page, so what we can do is to clear that current page. So self dot current page dot clear, and now what we can do is current page dot push, and we can push t dot clone. Okay, so at this point we are populating the current page. Maybe one thing that we want to do is to keep the latest timestamp there, which is an option I64. So what we could do is to say self.next timestamp equal some t timestamp Hey Bert VS, how are you? So T is basically, why doesn't autocomplete? T is a track. So we can go here. Right, T is specifically a recorded track. So we can go here and we have date. That's why it didn't autocomplete. T.date. And now we want to get timestamp in second, which should be this one, I believe. Perfect. Now here there is another thing we should be doing, which is basically to do if no timestamp fetch first page, otherwise fetch next page using the latest timestamp as the limiter. So we have a question in the chat from Bort VS, who is asking if I can put that on screen. Are you learning Rust just for fun or considering switching a stack? That's a very good question. I think it's a little bit of both. I am a full stack developer by trade. I've been doing that for probably close to 15 years at this point, mostly using JavaScript, but also used other languages like Python, PHP, Java, a little bit of Go. But lately, and lately means in the last 3 years, I've been really interested in Rust, and I've been learning it on my own time with small side projects like the one that I'm working on today. But I do anticipate a big uptake in Rust. I've seen already a lot of interesting serverless projects where using Rust, for instance, in Lambda, it is very effective. It makes a lot of sense because it might be much faster. It might be saving you a lot of money because it is faster and uses less memory most of the time. So I expect that it's going to become also a very interesting professional driver, meaning I will probably be working more and more on Rust projects in production. So having that skill is going to be useful. I hope that answers the question, but feel free to ask for more. Okay, so definitely we need to deal with this to do later. So what we want to do now is to see, let's actually create a very simple test so we can start to play around with this code. Let's do use super. And do I want to do a Tokyo test? Yes, of course, because this is going to be async, most likely. Test client, yeah. So we want to create a new client from env. By the way, I created this from env helper, which basically reads my .env file, so I don't have to show you my API key. And in this .env file, I have my actual API key. And then what it does, it runs this now playing .await, and this now playing is going to fetch the next page because that's the way we defined it, and it's going to print the now playing, which if I'm not listening to anything, it should be none. But I also want to print ln the state of the recent tracks. Is it recent tracks? What did we call it? Current page. So I want to do current page, which should show us all the other items in the page. Now here Clippy is telling me that I could be doing this way. Is it this way or is it this way? I can never remember. Perfect. Okay, let's run this and let's see how it explodes in my face. It did. Oh yeah, last.fm API key not set. Because, yes, that makes sense. I'll need to do something slightly different. But meanwhile, we have another question. So why not Golang? Much easier and job market is rich with opportunities compared to Rust. That is also a very good question, and I don't disagree with your observation. I think you have a point saying that Golang is definitely easier, and probably the job market for Golang is more mature at this stage. But I did actually use Golang for a production project, and I was quite impressed on how easy it was for me to, without knowing any Go in advance, I was able in 1 week to learn Go and deliver that particular project, literally in 1 week. And I was actually converting that project from JavaScript to Go, and it was just for performance reasons. And the performance was actually quite amazing. It was 10 times faster than the equivalent JavaScript. One issue though that then I bumped into later on was that I started to have a bunch of null pointer exceptions every once in a while in production. That was a data processing pipeline, so sometimes I would get some kind of bogus data and the code wasn't written well enough. But I think the reason there was that I didn't anticipate null pointer exceptions in Go, just because, of course, in a week I didn't really learn everything that there was to know about the language, and I kind of gave for granted that the language itself would protect me from null pointer exceptions, which was not the case. So of course I did fix all these issues in production, and that code was fine, and that code is probably still running in production right now, even though I'm not working in that company anymore. But I think that kind of pushed me a little bit more to explore other languages, and in particular Rust, because Rust seems to be in many ways a little bit more lower level, because it kind of gives you more exposure to memory constraints that you don't really have to think about in Go, but also gives you a model that I prefer a little bit when it comes to errors and optional values, because it tries to prevent, well, literally the null type doesn't even exist, so you cannot really have null pointer exceptions. And also the way that errors are managed is very interesting. And now that I'm kind of becoming more fluent with Rust, I actually prefer this model rather than the one that is available in Go. It's a total personal preference. Like, of course, that doesn't mean that people shouldn't learn Go and should learn Rust instead. I think there are pros and cons in going with Go or going with Rust. So pick your favorite. And of course, depending on which kind of industry you work into or what is your previous kind of knowledge, you might have a preference for one or another, and that's totally fine. Okay, so what I did forget here in this test is basically to say, to use this .env OK, which is the one that actually loads my .env file. Now, this is probably something that I'm not going to be doing in a test, because don't do it here. In a test, I will probably do mock the HTTP requests somehow, because of course I don't want to push my .env file in my CI/CD. But for now that we are just running the test locally, this is probably fine. Now, in order to use .env, I think I need to import the crate. Do I? Yes. Oh, actually, I can do that just in the tests. Perfect. Now, if we run this again, it might explode in a slightly different way. Or it doesn't. It didn't. But also we are getting an answer that I did not expect. We get an empty array, while I was assuming that the following would happen. So we created a new client, and then we called the nowPlaying method, which is going to trigger the load next page. So this code should run. Oh yes, of course, if I'm not awaiting this one, that doesn't do what I was expecting it to do. So that's interesting. Okay, here we might have to reconsider how to deal with errors. Yeah, this might be a result of an option now playing track, but let's see. Okay, now this is probably gonna do what I was expecting it to do. So it's gonna trigger the next page, it's gonna wait for that page to load, and if it is successful, it's gonna wrap it. At that point, our data is going to be populated, and we return a reference to the current now playing. If we are listening to a specific track, we are going to be printing that track. And anyway, we are going to print everything else that was loaded in that first page. Okay, this did explode, which is somewhat progress, I guess. Let's see how it did explode. So, panicked are not yet implemented in line 73. I probably have a to-do somewhere. 73, yes, I forgot here this to do. So here we just need to return an OK for now. Okay, so let's try again. Nice. So we got some data. We should have like 50 different tracks. So probably we're not going to be able to run this. So let's see. How can I do this? I can do here cd source last.fm and then cargo test. How do you test a specific file? I actually don't know this. How do I do that from the CLI? Test only this package library unit tests. Or binary or beans, examples, test. Test only the specified test target. Okay, so probably we can do this. And the name of our test, which was test client, I guess. Let's see if this works. Nope. Can we say client.ors instead? Nope. Okay, let's see. Cargo test specific test. I am searching in another window. Okay, so something like this, but test fn should be test client. Why didn't we get any output? Not what I expected. Should I still say? Okay, let's remove this flag. It did run this one. Last.fm client tests test client. But why we don't get any output? That's interesting. Okay, does VS Code give us any command there? It doesn't tell us exactly which command is being executed, or does it? Okay, we can do this other thing where we say this okay, cargo test display output. We need to pass a property called no capture. Yeah, thank you, WGaffa. I just found that out as well. So basically we need to say no capture. Is it no capture? Oh, without the dash. Cool, and this is what we want to see. So now we can pipe it to less. And that should give us something a little bit more readable. Okay, the first thing is none, because we don't have a now playing song. And then we have 50 different songs. Cool. Okay, so that seems to work. One thing we could do to continue the test is, where is my Spotify when I need it? Not there. Let me start Spotify. So I'm playing something right now that I don't think you can hear, but let's see. Didn't work. Still not working. Right. Maybe there is just a bit of delay on the API. No. Okay, let's double check something. So this is my profile, and it's not showing that I'm listening to something, so this is correct. Let's see if that changes. Okay, now I'm listening to something, this particular song. Let's see if the CLI works. Perfect. Now we have some, and it is actually the song I'm listening to right now. Cool, so this works. So we can move to the next step. And the next step is basically we can try to implement these recent tracks here. And what this needs to do, actually before doing that, let's make sure we know how to propagate here the timestamp parameter. I should have an example in JavaScript somewhere where basically I should have a function. Let me open that one. So this is some code that I wrote in JavaScript. It's an actual library that you can use. It's published on NPM and it's called Scrobbles. And you can use it to do exactly the same thing that I'm trying to do in Rust. So if you use Last.fm, you can grab an API key and you can use this to download your entire history of songs from Last.fm. And this is built in JavaScript by using async iterators. So sounded like a nice example for me to experiment streams or async iterators in Rust as well. So here we have a function called makeURL, which is the one that we want to look at. So what this one does is basically saying that if we have an option called from, this is the one that we need to pass. Then what else do we pass? Limit. Okay, probably we just need to specify this parameter from and use the timestamp there. I'm gonna take this guess for now. So what we want to do here is basically say, oh yeah, okay. So here what we need to do is something like this. If let some timestamp next timestamp, we want to we don't want to reassign the URL, like we don't want to shadow it, we want to reassign it. And do we want to use a to as well? Actually, yes, this is a little bit twisted to think about it, because here we are dealing with dates in reverse. So we are going to the most recent to the oldest. We basically have to say, give me data to this point. So we need to use the to rather than the from, if I remember correctly. So here we have to say to and this timestamp, and we can remove this one. Now, is this gonna work? I don't really like this approach. I hope that there is a way to mutate the URL itself. Is there like a with query string parameter? Query pairs mute dot append pair. Yeah, that sounds better. Okay, and now just for debugging reasons, I want to print, no, I'm not going to print the URL, otherwise you're going to see the API key. Let's try this in a different way. Let me think. What can we do? We can call again the now playing await, right? And that should fetch the next page. Okay, so this basically should fetch 2 pages. It might not be too obvious, but basically by calling now playing, we are fetching the next page. Okay, it didn't explode. So now let me try to do this here. And what we want to do, we are not listening to any song right now. There is an array here. So the first track here is Muse. So if I search for the next array, what do we get? How do you find for an array? Okay, there you go. So is this the next page? Let's see. No, this is still the first page. So let's go next. Pattern not found. Okay, this is the second page. So it's finishing here and starting here. So let's check the timestamp. The last timestamp here is 20th of February at 9:58. So in the next page, I expect to have a timestamp that's somewhat closer to that. And it's What is it? Come on. Oh, there it was. 02/20/956. While this one was 958. So it makes sense. It is going through pages somewhat correctly. We should eventually write some tests, but for now I'm more interested in getting a proof of concept going. Okay, now we should have enough. So basically here what we want to do is, because we want to yield recorded tracks, so probably we'll need to do another thing. We will need to do, oh yeah, we have here retrieved tracks. Maybe we should call this something like current track in page 0, and this one can be a usides. So this current track in page is 0. So what we can do here is to do this. We can say so when we start the stream, the first thing that we need to do is definitely call self, load next page, await, unwrap. Then at this point we need to say if there is a data. Actually, we don't need the index. We could just pop from the current page. Right, let's not do this. It's probably easier to just pop. And if there isn't anything, we'll do something else. So what we want to do is okay, let's do it this way. So let's do a loop. So we definitely want to do a loop, and then we'll figure out exactly when to break. Now what we want to do is if self current page is empty. Now let's do a match. Match, and we can do self current page pop. So if it is none, what we want to do is load the next page. I don't know why it's complaining about this stuff. Otherwise, we just yield t. And that should pretty much do it, right? That should be what we want. Okay, now why doesn't like S? Capture lifetime that does not appear in bounds. Really? What do we need to say? Like plus this? Okay, fair enough. So here we don't have a mechanism to stop. So probably this guy should return something that tells us when we can stop. Okay, so we did this one. So let's just return a boolean where basically what can we do is we return self current page is empty, And in this loop, what we do is let isOver equal this, and if isOver break. So this is going to keep calling the next page until it gets an empty page, which means we go to the end of the iteration, and at that point we stop this loop. Now the interesting thing is, how do we use this? So we need to look a little bit more at this crate. So there is this crate called stream. Well, there is a macro called stream that comes from a crate that I was looking at here. And this crate basically allows us to easily build an async iterator, or a stream if we want to call it like that, by using this yield keyword, which is not really in the language yet. So the macro itself is going to convert this code into like raw futures, and it's going to make sure that the futures are awaited correctly until there are futures. So the way we use it, we need to use this pin mute. So what we can do here is, and then this while let. Okay, so let's look at this. So we can get, rather than using now playing, let's call recent tracks, and we can do client dot recent tracks dot await, I believe. Yes. Why complaints? And at this point we can pin mute recent tracks, and now we can do this. Okay, pin mute needs to be imported. And now this next doesn't work. Why? Okay, this await is not happy. So what does recent tracks return? Oh yeah, I don't need to await, right? Because it's already a stream. Okay. Now, why doesn't it have a next if this is a stream? Do we need to somehow do something special on the pin? And this is where my knowledge of async is probably not good enough. So if you have any suggestion, please help. So here they were creating a stream, and this is what we return from our function. They pin it, and then they just do this s.next.await. Oh, probably we need to bring this guy as well in scope. Right, let's try that. Okay, that seems to help. And now we got a value, and a value is a recorded track. So what we can say is this is okay, let's give this a go. So what we expect to happen is that we will get, actually let me try something else very quickly. In fetch new page, what I want to do is here saying something like print ln loading page from timestamp. Okay, now we can run this code. let's see what happens. So it's saying got recorded track, and we get all the details. So there should be about 50 of them. I should have probably used something a little bit more visual. Oh yeah, there is a thing we can do. If I remember correctly, there is an attribute. Let's check the last.fm API. So there is a method called get recent tracks or something like that, which is the one we are using right now. Track user get recent tracks. So here we have the number of results to fetch per page. So we can pass this limit and set it to something very low for now. Limit rather than 50, we can say 2 to do change where remove this. And now if we run this again, we should see, and another thing I want to do is here, let's make it more obvious. Let's put an emoji. And now we should see 2 items. Okay, loading page from this timestamp. Another item, loading page. So this seems to be working. Now, is it gonna crash? We can make this run for a while. Actually, let's just do one thing. Rather than printing the entire song, we can just say something like this. So we want to do track dot date dot is there an easy way to print like ISO or something? To RFC, let's go with this one. And then we want to do track artist name and track name. Perfect. So now what we can do is, let's remove this one. Let's restore the limit to 50. And now if we let this guy run, we should get a continuous stream of data. Perfect. So this guy is traversing the entire history, which is what we wanted to do. So this is, I call this a success. And if you notice, the timestamp is going back in time, like 10 of January, 9 of January, 8 of January, 6 of January. So we could be building some kind of automation, maybe converting this to, I don't know, CSV or whatever. This is pretty cool. Now there is one thing that we might keep for next time, which is basically, because I've written this already in JavaScript, I know that this API is not always very stable. Sometimes you get random 500. And one thing that I implemented in the JavaScript version is the possibility to basically retry. In case of an error, it's going to retry a number of times before failing entirely. Now here I suspect that if we bump into this edge case where we get a 500, this is just going to straight out fail, which is not ideal, because here we will, if we want to fetch the entire history, this is gonna run for a while because I have something like more than 250,000 records. So this is probably gonna run for, I don't know, 1 hour or something. So it's just gonna fail maybe in between and I will need to restart from scratch. So yeah, we might want to improve that in the next episode. Oh, I see that Jocelyn is here in the chat. How are you? Great to see you here. But I think that at this point we are probably close to the end of the stream. So we have done quite decent stream. I think we have been streaming for what? For like 1 hour and 20. So yeah, generally do about 1 hour. So that's probably all I have for today. Okay, I'm gonna say hello to you from myself and Ferris. What I'm gonna be doing is I'm gonna clean up a little bit the examples and I'm gonna commit in my repository, which, just to give it to you again, is here. I'm gonna copy paste it in the chat. And yeah, I will continue next time with this. Oh, there is a question in the chat, so let me try to answer that because we finished for today. And thank you, Chris, for joining me. It's a pleasure to see you here. By the way, Chris, I don't know if you are aware, but I did a talk at Rust Nation UK this week, actually last week, and I had you in my initial slides where I said thank you to the overall community because I think I'm getting a lot of help from the community, and you in particular are somebody that is producing some amazing content. So thank you for that. Okay, the question was, sorry about that, I missed it, which is, I'm not considering doing system programming, but concentrating on web development, backend in particular. Node.js is the main technology I'm using these days. Your advice will be in terms of picking next tech. Honestly, I am a big fan of Node.js. And if you check out my bio, you will understand why. And I'm not gonna say drop Node.js and do something else, of course. Like, Node.js is a great piece of technology, especially if you're building web servers or anything that is effectively IO bound. You can get pretty good performance using a language that is quite high level. So go for it. Keep doing Node.js, keep using it. I think it's gonna be a technology that is gonna serve you for a long time. The reason why I'm personally learning Rust is, well, on one side I said that I see a lot of opportunities in the future, especially in the serverless space. But on the other end, it's a little bit of a personal challenge because I've been using for a long time high-level programming languages, mostly scripting languages, interpreted languages. I never really was concerned about performance too much or memory efficiency too much. And I always kind of discounted a lot of topics like how does even work when it comes to memory? What is the heap? What is the stack? Is the heap more expensive than the stack, and why? And I think by learning Rust, I can explore all these topics and actually appreciate them in an easier way than trying to do that with C or C++. So I don't know if this is just a long-winded answer, but my answer would be you don't necessarily have to learn Rust, but if you want to do that, there might be benefits in terms of you will be learning new concepts entirely, which can unlock other opportunities in your career. But if you want to stick with higher level languages, build web servers with Node.js and get a lot of experience with that and be very proficient with it, that's an option as well. You can always explore these topics later. So hopefully this answer is somewhat satisfying. But yeah, let me know if it isn't and if you have more questions. Okay, there is one last question. All right. Right. I'm glad that you have questions, and to be honest, keep asking them. Is where should I start learning Rust? This is actually an answer that a question that I'm prepared to answer to some extent. because I have written a blog post which is slightly obsolete in terms of title, but I think it's not that obsolete in terms of content. I'm just gonna drop the link here in the chat. And basically this article is something that I wrote with a friend of mine, Stepjan, who is also, well, when we wrote the article, we were both starting to learn Rust. So we were very excited and we tried to kind of write this article together, and we collected a bunch of resources that we thought were the best ones at the time to start learning Rust. I think it is still quite relevant. There might be one or two resources missing there, but I think most of them are still very relevant, and they are still the same resources I would recommend today. So definitely go for that. And there are books, there are articles, there are free resources, paid resources, so you can definitely pick whatever is your choice for learning material. Also, I know that Chris Biscardi is working on more training material and learning material, so definitely follow Chris. Check out his YouTube channel because he publishes a lot of cool videos, but I'm sure that he's going to come up with new structured material, which is going to be amazing, like everything he does. So while I search for Chris Biscardi YouTube channel and drop the link, feel free to ask more questions, or I'm gonna stop the stream here. Okay, I have the link. There you go. And yeah, that's awesome. Thank you very much for being with me today. I had a lot of fun. I'm actually quite happy that what I was trying to do worked to some extent. It's not clean, but we can always clean it later. So see you next time, and thank you everyone.